Okay, I'm going to give you the conclusion to this video first. Here it is. Don't turn your back on mathematics. Okay, here's the story. I have a friend named Will. Will has a brother named Kevin, and Kevin's married to an artist named Lisa Beck. So Will and I are in New York City where Kevin and Lisa live, and so we end up going to one of her art openings, and I see some very interesting things in her art. Let me show you. Okay, here's a piece that she's done. The first thing that I notice is that this piece, the corner of the room, is part of this piece. So she's using the corner of this room as part of the artwork itself, as part of the display. Now, what's interesting about that to me is this. Corners work like three-dimensional coordinate systems. You know, we have a two-dimensional coordinate system that we developed for graphing lines and parabolas and things like that from Descartes. If you just add one more dimension to it, you'll get a corner or a three-dimensional coordinate system, and from there you can name any point in the universe that you want. Now, what's also interesting about that to me is this. The mathematics that describes the universe is actually more than three-dimensional. Has 4 or 5, depends on what you're doing, how many dimensions you have. But our perception as human beings runs out at 3 dimensions. So that's all we can do. We can only perceive 3 dimensions. So if you see some artwork and it's placed in a corner, kind of to me it says, this is as good as it gets for us humans. We can only perceive things in 3 dimensions. And here's the artwork. Okay, the second thing I notice is this. I see a lot of little fractal kind of images here. I see patterns where you're repeating the same thing over and over again, just maybe smaller and smaller, so on and so forth, similar to what we saw kind of with that Sierpinski triangle. So after the reception, we go to dinner and I get a chance to talk to Lisa a little bit about her artwork. And so I tell her, you know, that I see some fractal kind of images in there and a little bit about Sierpinski triangle, that kind of thing. And she's talking to me about what she's doing, what she's trying to convey, and one of the things she says is a little like Zeno's paradox. And I thought, wow, Zeno's paradox, that's a really neat mathematical concept, and I'll show it to you in just a minute. But here's the point. Lisa didn't turn her back on mathematics. She knows enough about mathematics that it influences the way she does her artwork, something that she's really good at. So that's really the point of this whole thing. Whether you're going to be an artist or in literature or whatever it happens to be, don't turn your back on mathematics, because there may be something in there that really influences you in doing that thing that you're really good at. Let me show you a couple more pieces from Lisa. Here is the same piece now with some glass spheres, okay, kind of on the outside, and what I really like about it, here's the original artwork in the corner, and then when you look at the glass spheres, you can see the reflection of that corner in the glass. Another piece, very similar, you can see the reflection here in the glass spheres of what's in the corner here. Another landscape, and again, I can't help but see some fractal type things. Really a lot of fun to go to an art opening like this, see some things that look mathematical to me, and then talk to the artist herself and find out that in fact she was thinking in some kind of mathematical terms. Let's go to the board now and I'll show you Zeno's paradox. This is a little fresco that shows Zeno leading his students to a door marked truth. Now Zeno's famous for a number of paradoxes. I'm just going to paraphrase one of them for you, but you're going to get the idea. It's real simple. So Zeno's paradox, one of the most famous ones, I'm just going to write it in terms of things that we can understand here. Suppose this is school, this is home, and it's a straight line for you to go home from school. So you're going to walk home from school. This is the way Zeno reasoned. He said, well, before you go from school home, you're going to have to pass the halfway point. And that's true. At some point, you have to pass that halfway point right there. When you're at this point, before you go from here home, you've got to pass that halfway point. And before you go from here home, that halfway point, so on and so forth. And he reasoned that because that line is infinitely subdivisible, you never get home because you can never get through that last halfway point. You just keep subdividing, subdividing, subdividing. So let's put some numbers with it. If this is 1 mile from here to here, then this distance is 1/2 a mile. This distance right here is half of that, or 1/4. This distance is half of that, or 1/8. And this distance, of course, using your little inductive reasoning, right, is going to be 1/16. So here's Zeno's paradox. Either these numbers, 1/2 plus 1/4 plus 1/8 plus 1/16 plus ... add up to 1, and you get home from school, or you can never add an infinite number of numbers no matter what, and you don't get home from school. So either these numbers add up to 1 and you get home from school, or they don't add up to 1 and you can't get home from school. So it's a paradox. It looks like two things seem to be true at the same time. So Zeno had a bunch of other paradoxes that he brought to town. Everybody discussed them. They've been discussing them ever since then. So, okay, here are a few more pieces by Lisa. And you want to ask yourself, as you look at these pieces, is there anything in them that reminds you of Zeno's paradox? Or has the feel of Zeno's paradox? Or maybe that you can see how Lisa could have been influenced by Zeno's paradox. Anyways, quick look at Zeno's paradox, and I wanted to relate it to Lisa Beck and the artwork that she did and how she described some of what she did as kind of reminding her or in the vein of Zeno's paradox.